Welcome to the trials and tribulations of my 8-bit breadboard computer build. In this video, we will continue the troubleshooting phase of my project. We solved the issue of needing functional replacement components in the last video, and now we're left with some more complex issues with Kit 2 as well as Kit 3. Now, we started with Kit 2 in the previous video, and we've considered rewiring, as well as adding insulation to the LEDs, and facing a problem with the power when we connected it to the clock. Things didn't start to power up correctly. So we've tried a few solutions, and we also need to find a way to successfully add in the 220 ohm resistors. I tried adding some extra breadboards to help space out the build, and I will add a link in the description below with the breadboards that I purchased from Amazon. Now, this is just an idea to try. I don't know if it will work, but it's something to cross off the list if it doesn't. So this is just all a part of the build and learning and trying new things and having to redesign and go outside of the schematic and outside of the videos and try to implement things on your own. As you can see in this video clip, I am just starting my troubleshooting phases, which is normally testing out the first kit, which is the clock from kit 1, making sure everything's working. As you can see, I was testing all the modes. I was also speeding up the clock pulse as well. So next, I do want to go ahead and make sure power is secure. And in this video, you definitely see me struggle with my adapter more times than one. So here I'm just going to go ahead and hook up power to the A register because I do want to test out the A register, make sure that's working, and then test out the B register. This register in my last video, you could see that I had spaced things out a bit, and also spaced things out with the ALU. But I'm not sure if that's going to work. So with the A register, it was okay with the 220 ohm resistors. I was able to make it fit. However, considering the ALU needs to be hooked up to the A register and the B register, I wanted to space out the B register and the ALU. So that's why I added extra breadboards to those specific parts, and I'm not sure if they're going to work. So far the register A has its own type of design with the resistors, and I'm just trying to see if maybe I can space things out with the B register and the ALU, or if it doesn't work, I'll have to just try and find a way to make it as identical as possible to the A register with the resistors, and as well as with the ALU with the LEDs and the resistors. So as you can see here, I'm wrestling. It looks like I'm arm wrestling my adapter to make sure I can get a secure power source, and it looks like my A register is lighting up accordingly. However, I'm going to try and load onto the bus. It looks like I only have 4 LEDs hooked up on the bus, so that's okay. As long as we can see some transfer is happening, then we can just add on more LEDs and test on the other ones. So at least we're getting positive results. Just having issues with that adapter again. And then now I'm just going to go ahead and try out with the B register, as I mentioned, with a little bit of a different design with the extra breadboards to space things out. However, it doesn't look like the B register is working. So unfortunately, I don't think that those extra breadboards are helping me in this situation. So back to the drawing board, back to brainstorming and trying to think of a new solution with those resistors and the B register and the ALU. And I still have to add resistors to the rest of Kit 2, like my ALU needs resistors, the instruction register needs resistors. So in addition to rebuilding the B register with resistors, I'll have to make those modifications to the instruction register and the ALU. But now we're going to move forward and have a quick recap of where we are so far with my build as of now. And hoping to troubleshoot my ALU, I went ahead and redid my B register with spreading things out. I added more breadboards due to the resistors that we were adding. I added some to the A register, but because of the positioning of the B register, I decided to add more breadboards to the B register as well as to the ALU. And I wanted to give a better demonstration of what the results look like when testing the redesign. So I am troubleshooting the main issues of my ALU and the RAM. Now with the ALU, I'm verifying that the registers are wired correctly and adding those 220 ohm resistors. I'm trying to incorporate some color coding for better organization. We changed the LEDs here on the B register to blue versus red. So the A register is red LEDs, the B register is blue LEDs, and then we have the instruction register here that we have also revised, and then the ALU has white LEDs. So this again is an attempt to spread things out in hopes there will be less interference and more stability with the electric currents, helping with the resistors since I do have a wacky power adapter. But let's go ahead and move forward to the test demonstration. So here I'm starting to test out my build. I'm starting with the clock, and then I'll proceed to the A register and the B register. Now you'll see that the B register is lighting up, but only partially. So that might be an issue with the resistors or possibly needing new LEDs, verifying that the polarities of the LEDs are on the correct pins, or maybe making sure that the wiring is correct. So we're halfway there. We know the extra breadboards also might be an issue. However, I just wanted to show you what the results I was getting on a full scale of the overall build. That way you can see everything. So the A register should be enabling onto the B register, and both registers should have all the bits lighting up, displaying ones. But as you can see, that's not the case. We also wanted to test out the A register and the bus, and see what's going on there, and make sure that also the bus and the B register are working as well. But it doesn't seem like the bus and the B register are working. They are working with the A register as mentioned. There's only 4 LEDs hooked up to the bus, so I'll have to add more and test it out further in the future. But again, with the B register, it might be an issue with the resistors. Maybe I need to rewire things, but I need to fix up a design that matches the A register. Now, my instruction register is also not working correctly, so I do have to redo my B register and then add resistors to my instruction register, and then I'll have to try up hooking up my ALU. That also needs resistors. So moving forward, I'm just going to test out the blue LEDs and see if I just need to swap them out, and then I'll try to make the design match the A register. Aside from redoing the B register, I wanted to take a look at the ALU and show how I am color coding the ALU. Now, as I mentioned, the LEDs are white. The blue wires are going to be used for the inputs from the A register, and then there are the inputs from the B register, which are in green. But I'm going to redo it since the extra breadboards are not helping as I'd hope. And I'm going to try to test the LEDs, squeeze them in a little bit with the resistors on one breadboard and leave these extra breadboards for the bus at the end of the build. We thought this would help, but it actually is causing more problems than solving them. Another note is on the schematic. Things can get a bit confusing when you're following the wiring on the schematic, and I would suggest labeling to stay better organized and understand how everything is hooked up. So here specifically, the LEDs and the pinouts are a bit backwards. The first pin on the 74LS245 or the bus transceiver chip is usually connected to the last LED bit. So that can get a bit confusing, so be wary of that and label as much as you can. So the first thing I'm going to do is just test out the blue LEDs and make sure they're all functional before I start to actually take apart the B register and the ALU.
Just pay attention to the polarity. Remember, the longer ones go on to the positive end and the shorter ones go on to the negative end.
So I tried to space things out with the extra breadboard since the B register is just below the ALU, but it proved to be unsuccessful. So now I've rebuilt the B register, making it as similar to the A register as possible with the 220 ohm resistors, and now we're going to start testing out the second redesign. So the second redesign is much simpler. We're just smushing everything together on one breadboard. Now here you can see in this clip, I'm trying to test the registers in the new design, and there's a bit of an issue with the power. So I just try to simplify again and test each build on its own before I try to put everything back together again. And we're just going to start off with the clock. Here I'm just disconnecting some things. Now this entire project is sensitive, so it can be a little bit unstable, and with my power adapter, that doesn't help. So I just try to go through everything and solve each problem I run into. For instance, the clock. Here I'm plugging it up. I'm going to plug it up to power. And we'll go ahead and see what's going on. Is it working? Is it not working? Now, as I hook it up, you can see that it's not pulsing anymore. The timer isn't working. Sometimes you just have to push in some of the pieces into the breadboards. You know, sometimes they get out of the pinouts, they unclip. So while I was verifying everything, making sure it's pinned up where it needs to be, it just takes me a minute or two to get the clock working. And I think I just had to push in a resistor. So it wasn't too complicated, not too bad. Now, after I see that the clock is good to go, I move on to the A register. Now, with the A register, I just want to make sure that it's able to load data using the pulse of the clock. So when the clock pulse goes high, or 1 is demonstrated, all of our bits should also be high or demonstrating 1s on the A register. That's what we see in Ben Eater's YouTube videos, so that's what I'm hoping for in this test. So here, I'm just testing the A register, trying to stabilize the power to the build. There we go, and now we'll set enable, and we get all 1s. So that's the expected results. That's good to go. Now we can move on to the B register, which is what we really want to see demonstrate all 1s when we enable. That's what we really want to make sure is working, at least in that sense. And then when we have the bus and it comes to inputting data or setting data onto the registers, we'll go through those tests as well. But for right now, just want to make sure we can load something, load all 1s using the clock pulse. So here I'm hooking up the B register, and we're going to go ahead and hook up the power, hooking up the clock, and then we'll set enable, and great. So it looks like we're getting all 1s. It looks like the second redesign attempt was successful. So that's wonderful news, and now we can move on to the heavier duty stuff like the ALU. I also added some labeling to the build to make it easier to remember and memorize the pinouts. And then here is the ALU that we have to redo now. The rest of this video is dedicated to documenting every step of the reconstruction of the ALU and its architecture. So here I'm just redoing my ALU. I am connecting on my outputs from the A register. I'm connecting them in red, and yellow we're gonna have the sum outputs, and then I'll connect the B register with blue wires, just color coding it as I go, since I am gonna be adding resistors. I've changed the design a few times, and it wasn't working any better. So now I'm just going to try to go back to the original design and just add those resistors and test everything together. I'm having an issue where as soon as I start putting the breadboards together, the power won't sustain to everything so that I can actually test all the parts to work together. So that is a bit frustrating. So here I've added all of the outputs from the binary adder to the bus in yellow. And I try not to put them all in the same row, trying to split things up a bit to see if that will prevent some interference from my breadboards and with my power adapter. And as I mentioned earlier, I am color coding, so as we go. So yellow are essentially the outputs that are going back onto the bus, and then here in red, we have the inputs from the A register. As we've progressed through this rebuild, things are known to get messy with the ALU especially. As Ben Eater mentions in his YouTube videos, you're adding all of these wires. You have to add the B register to the XOR gates, and already you can notice things are getting a bit congested and complicated, even so with having to add in the 220 ohm resistors, so space is limited. And the way that the A register is positioned, there's easier access versus having to navigate to the B register here. And if this continues to be an issue, I might have to widen the connection and go around the build, but we have to find a stable design that also works with the resistors. As mentioned, we have less to work with, space is limited, and I've tried to make sure that they aren't interfering and placing the wires in different rows to try and mitigate congestion, which might be due to my power adapter or the breadboards. As we've noted previously, when we start to add the breadboards together and power everything up, it seems like there's no power going through. So there might be, some issue with congestion, as I mentioned. It might be due to the congestion, but so far this is what I have after adding in the B register. So we're still color coding. So from the B register to the XOR gates, we are using these green wires here. We've already used the green for the LEDs, so we're just doing that. And then the blue wires will do the results to the 4-bit adders. We have 2, so that's 8-bit adders. And then those will be going back to the bus. Now, like I said, we're still color coding. Green is going to be for the XOR gates. The results will be in blue, and then we'll proceed to hook these up to the adders. Now here we can clearly see the B register or blue register hooked up to the XOR gates in green. And now we've connected those results to the binary adders with the blue wires, along with the results to the A register that we've already hooked up with the red wires. So this is just a breakdown of the color coding. And then here I'm just spreading out my LEDs since they're kind of smushed together because of the resistors. Moving forward, I've connected the second inputs of our XOR gates. So these second inputs are for subtraction. So you can see I've added that portion in black, data from the B registers in green here, and then we have the subtraction in black. And finally, the results are going to be in blue here. So now that we've added on the subtraction bit, we can go ahead and set this up as a signal. And essentially, when we set this signal high or low, depending on if we're adding or subtracting. So low is adding, high is subtracting. We'll leave it as low for now, and I'll probably try to find a better jump cable to secure it a little bit better into the breadboard.
So in addition to adding the subtraction inputs, we also need to add 1 for the 2's complement. That way we can get the subtraction in binary correct.
So finally, we went ahead and added the carry in. So when we're subtracting on the ALU, hence when the signal or the jump cable is set to high, we'll have a 1 there. And then that can be sent, that signal can be sent into the carry in, and then we'll get the 2's complement for subtracting in binary. Now we're going to go ahead and stop here. In the next video, we'll continue and see how this reconstruction of the ALU pans out. Thank you so much for watching.